It is often of interest to compare values in a data set. To do this, we can use some measures of relative standing, how one value compares relative to another. Three measures of relative standing are z-scores, percentiles, and quartiles. And in this video, we'll look at z-scores. So z-scores represent the number of standard deviations that a given value x is above or below the mean. So we'll find this value x, this particular test score, and we want to know, well, how many standard deviations is this test score above or below the mean? And the z-score will give us that number, how many standard deviations that a particular value is above or below the mean. And we always round z-scores to 2 decimal places. Okay, we have two formulas because we may be talking about sample data or population data. Usually we'll have sample data, but sometimes we do have population data. So for a sample, the z-score, z, is calculating by taking the value of interest, x, minus the mean value for the sample. How different is this value we're interested in? How different is that from the mean? And obviously, if it's greater than the mean, since we're putting it first here in the difference, we'll get a positive number that will indicate above the mean. If this value is less than the mean, say we scored below the average on a test, then we would get a negative in the numerator, and that would give us a negative z-score, and we would know we were below the mean. So x minus x bar, and then to determine how many standard deviations is that, we'll divide by the standard deviation. For the population, we take our value, and now we use the population mean, which is mu. Same idea. What's the difference between the score we're interested in, the value we're interested in, and the average or the measure of central tendency for this data set? And then divide that by the population standard deviation. So it just depends on which we're dealing with, a sample or a population. Okay, let's look at an example. Okay, women have heights with a mean of 63.6 inches and a standard deviation of 2.5. So the way this is worded, it's not talking about a sample. It's saying women have heights. So we actually have population data. Now that doesn't mean that they've actually measured every woman, but it does mean that they have so much information on this, and this is the case, that we could consider this the population mean and the population standard deviation. And then we have this information. Vanessa is 70 inches tall. Dana is 62 inches tall. So for each of these women, we want to determine the difference between their height and the mean. So let's start with, so let me write this down up here. We have this population mean of 63.6 inches and the population standard deviation of 2.5 inches. Okay, so for Vanessa, what's the difference between her height and the mean? Well, Vanessa is 70 inches tall. The difference between her height and the mean height is 6.4 inches. Okay, for Dana, her height was 62 inches. So the difference between Dana's height and the mean height of all women comes out to be a negative 1.6 inches. So you see the difference between someone whose value is above the mean, and we get a positive result, and below the mean, we get a negative result. So now we know the difference between their height and the average height of all women. Well, how many standard deviations is their height away from the mean? Well, for Vanessa, the difference was 6.4. How many standard deviations will go into 6.4? So we divide that by 2.5, which was our standard deviation, to find out, well, this difference, how many standard deviations are we talking about here? And when we divide, we get 2.56. So what that says to us is that Dana's height is 2.56, a little over 2.5 standard deviations above the mean. Now we know she was taller than the mean, but we also got a positive result, so that gives us that clue. Let's look at Dana. How many standard deviations away is her height from the mean? Well, the difference between her height and the mean was negative 1.6 inches. And we'll divide that by the standard deviation of 2.5, and we get negative 0.64. Okay, so she was, in just distance, 0.64 standard deviations below the mean. That's what the negative tells us right there, that her height was actually below the mean. Next, we want to convert their heights to z-scores. So using the formula we had before for Vanessa, remember the formula was z equals x minus mu, Vanessa's height minus the mean height divided by the standard deviation. So Vanessa's height was 70, the mean height was 63.6, the standard deviation was 2.5 inches, and we get 2.56, which is actually what we saw before. We just did it in steps. First we found the difference. What's the difference between her height and the average height? Well, how many standard deviations is that? So we divide by the standard deviation. So that's really the thought process of this formula. And let's do the same for Dana. Her height minus the mean divided by the standard deviation. This should be sigma. Let me make that correction because we have population data. Okay. And Dana's height was 62 minus the mean divided by the standard deviation, and this is where we get that negative 0.64. So the z-score tells us how many standard deviations away from the mean. If we get a positive number, we're above the mean. If we get a negative number, we're below the mean. Another question we might be asked then is this unusual? Is Vanessa's height unusual? Well, remember that we said that usual values fall between 2 standard deviations above and 2 standard deviations below. So we could actually use this number 2 now. Instead of saying 2s, we know that a z-score is exactly number of standard deviations. So 2 standard deviations would be our cutoff for maximum usual, and a negative 2 would be our cutoff for minimum usual. So we could look then at Vanessa, and Vanessa's at 2.56. So because 2.56 is greater than 2, we would say that yes, Vanessa's height is unusual. For Dana, we would say that negative 0.64 is greater than negative 2. It falls in this usual area. So no, Dana's height is not unusual. Unusual would be all the way down to negative 2, beyond that, and she was just at negative 0.64. So this is another way we can interpret this. Once we calculate our z-scores, then we instantly know if we get a number above 2 or below -2, we instantly know we have an unusual value.